Hello everybody, Chaz Large here with another Fix It video for you, and on the bench today we have got this lovely old beastie of an amplifier and tuner. It's a Pioneer SX434. It's a good old beastie. I've worked on a few of these before and I'm fingers crossed hoping that it's actually got the same fault as what I've encountered before on one of these. Now just switch it on quickly. We can see if I turn it on, we've got sound output, so the output stage is all working. If I switch it to AM radio, AM radio is working perfectly. Switch it to FM, got an FM aerial connected to it through the tuning band. Absolutely nothing. It's not picking up a single thing. Now, as I said, the fault that I've had before on one of these is to do with the front end. Let's just turn the volume down and get rid of that hissy noise. So if we bring in the circuit diagram for this, we can see we've got a fairly standard front end circuit diagram consisting of an FM and AM front end. Now the FM signal goes through the preamplifier, which is an N-channel FET, into the mixer, which combines with the local oscillator here and provides FM input into the demodulator, which is the HA1137. Now if I inject some noise into this front end signal here, which I can show you by basically just putting a little bit of noise into the circuit. Let me just get an overhead view so you can see what I'm going to be doing here. So the front end circuit, just zip that round there and zoom down into it for you. So if the FM aerial connection comes in here to the front end, so we've got the front end FET in this little box here. Then we've got the mixer amplifier here, which is Q2, although on some diagrams it's labelled as Q10, and then Q3, which is the mixer which is here. The output comes through this coil and eventually goes down through these two ceramic filters just here and into the demodulator chip there. So if I introduce signal into here, that pretty much tells me that this part, the demodulator, is working. The problem is with the FM front end. Let's have a little look on the circuit for that. I'll put it down the bottom corner here. So that's our FM aerial coming in through the FET, in through there, in the pre-tuned circuit, there's the mixer, the oscillator, and Q2, which is the mixer, and that feeds through into there. So by putting signal into here, into this front end ceramic filter, we know we're getting signal through. So the fault has obviously got to be around here somewhere, but we're not too sure where. Now I did, as I said, I have had this fault before, exactly the same fault as before, and the fault was to do with Q2. In fact, Q2 had actually failed completely open circuit. I'm fingers crossed hoping that it's going to be exactly the same fault. So what I'm going to do now is I'm just going to turn it onto its side and get my test meter onto Q2. You can see on that circuit we've got some voltages written. So on the base of the transistor, and I've got another, where's the other tab gone? Bear with me a second. So over here we've got Q2, which is the one we're interested in. There's Q3, which is actually labelled Q10 there for some reason, and Q1, which is the FET. So if we go straight to Q2, which is there, let's just get rid of that. We don't need the demodulator chip. So we're going to be looking at the base of that. Now on my previous repair, when I got it working, I took some voltages, and these voltages are about right. 2.2 volts on the base, 1.45 on the emitter, and 13 on the collector. Well, 13 on the collectors because it comes from the supply rail through this coil here. So we should be able to go on there with the meter and check. Let's just get rid of the diagram for a minute. I'll turn that around there, you should be able to see. The base we've got 2.1. Okay, and we should have 2.2. The emitter should be 1.4, and that's actually reading 0.6. And the collector, which is there, that's the collector, 11.9. Right, got it right. That's definitely the collector, and we can see by interfering we're getting something out of there. The base is, as we said, 2.1. The emitter is virtually 0. There we are, 0.9 of a millivolt. So I'm pretty certain that the fault is going to be that transistor, which is open circuit. So let's get that out of the circuit board and give it a check. Soldering iron's nicely warmed up. Let's get a bit of desoldering braid on there and pull that transistor out. On there. On there. Can I get it by hand? Yes, I can. Look at that. So there we have the transistor. Let's go into test diode mode on our meter. Go on to that pin, to that pin, nothing. That pin 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 to that pin, that pin to that pin, nothing. Well, there's a little flicker there. Was that me touching it by mistake? Yes, it was. Oh no, well, hang on. We have got something there, but nothing to that one. So it's not completely open circuit, all connections, it's just one. The transistor is definitely kaput. Now, thanks to having a collection of old data books like these, including this beautiful old book that I bought many years ago. This is a semiconductor replacement guide from Tandy, or Archer as it was back then. And basically with that one you look up the device in there, and it gives you an Archer equivalent. So the transistor that's in there is a 2SC434 according to the circuit. I've printed a circuit out, so it's 2S, where are we? 2SC 4, 2SC5, 2SC535, and that comes out as a Archer reference 2762038. If we look in the front of this, it gives a list of the Archer transistors. (2038), and it's an RF based transistor. An equivalent is a 2N3866. Now I haven't got one of those, but using another lovely old reference book, this is a Towers International Transistor Selector. I looked up the equivalent in this, hoping that it was going to be the same fault, and my diagram there, and a UK equivalent is a BF223, and lo and behold, I got one out. I actually still had one left in my box, a BF223. So all I've got to do is fit that little transistor in place of that one with longer legs. So what I'm going to have to do is just tack on some longer legs, because it's got to go in the can. I could tack it on the underside of the circuit board and it will probably work just as well, but I want to put it in the can just to make sure it's right. So bear with me a second while I just get some bits of wire and get that prepped. Right, here we are. I've done a little bit of preparation on this transistor. I've put some very fine wires onto this so I can put it straight back into the right connections. There's my circuit diagram with the notes that I've dug out. There's the transistor base emitter collector. So I need to just get this into the right position on the circuit board now and get that wired in. So I'm going to turn this round. Now there's not a lot you can see, to be honest, while I'm doing this, so I'll do it this way round. But I can see on the circuit board itself, in fact I can show you that. If I open this and then switch this over to the circuit board view, which there it is, so you can actually see on here, on the transistor itself here, they've got this markings, and this marking actually is laid out on the top side of the circuit board. So with the base going into there, the emitter, which is in the middle, and the collector, we should be able to get it with these fine wires straight in. Alright, one's bent up, so let's just straighten those out a little bit. I have to put my old specs on because I just can't see close enough, and I need a little bit of light there as well. So let's try again. Base there. Clean the holes so the pins, the wire should go straight through with no trouble. And there it is, it's in. You may just be able to make out the wires I'm pulling through. It's purely because I don't have, I mean I could order an equivalent transistor with the right length of legs, but if I've got something that will do as an equivalent and it just needs longer legs, I'll just extend them quite happily. So solder that in. There's one. And all I did to extend these legs was just to take a bit of braided wire, strip it back, wrap the wire around each of the leg, solder it, trim off the little short edge, so I'm left with 3 long legs. And now all I've got to do is cut off these excess. Three. Let's see if it works. Apologies if there's some camera interference. One of the cameras. Oh! It's working.
It's a simple one. A king barred his queen
there we go.
From entering.
the fault. That was the problem with it. That was indeed the transistor here in the front end of the FM. Q2 had gone open circuit between one of the connectors in there, and that was the cause of the problem. I guess if I go back now and check the volts, I'm sure I'm going to be about right. So that's good. The rest of the circuitry seems to be fine. All the big capacitors on the power supply, they all look okay. I guess for safety's sake, there's a couple here that I don't think they're at fault, but maybe for long-term reference, maybe, or yeah, those two actually look like they've just stretched the plastic a little bit, as do those two. So I think these two big ones here I think are okay. It's these smaller ones here on the lower supply rails, they look a little bit like they've begun to sweat a little bit and stretch. They're not quite as over the top on the connectors as before. So I think what I'll do before I send this back to the customer, I think I'll change those capacitors. But otherwise the rest of it seems to be working. All the other functionality is okay. I'm pretty certain that the A and B speakers are going to be working. I'm pretty sure that the auxiliary input is going to be working. Right, one thing I need to fix on this tuner amp before I send it back to the customer is to fix the stereo indicator. This is, yeah, it's back to music, but at the moment it is actually in receiving a stereo signal, BBC Radio 1. I can't turn the sound up, otherwise we'll have a content match. But believe me, it is in stereo, but there should be an indicator light just here which tells the user that in fact there is a stereo signal being received, but it's not lighting up. I suspect it's nothing more than a faulty bulb. The bulb is here in this block here. One side of it goes down to the 13 volt rail. I've checked that end, it's definitely 13 volts, and the other side goes up through this hole down here to this pin, this tie wrap pin. So I'm guessing that if we unwrap that from that pin, and then we turn it over, switch the power off so we don't accidentally touch something that we shouldn't. So I'm going to put my meter on to continuity mode, clip it to one side of that cable that I just unwrapped, and the other one is the other white one onto here. And yes, sure enough, the bulb itself is open circuit. So that should be a fairly easy fix if we've got an appropriate bulb. So let's see if we can get that bulb out of there. So the difficult thing about this particular part of the bulb is getting that front panel to a point where we can get at the... so the bulb indicator is there. Now I'm not sure if that's just wedged in there. Right, eventually got the camera, my little bracket assembly on the top of my camera had fallen apart, so I had to rebuild that. Anyway, got the camera into a position where I can see the back of this, and it seems the only way really to get into this is to have this front panel off. To take this front panel off means undoing the cord which drives the cursor along. So I'm going to see if just removing the front escutcheon area here and knobs allows me access to the bulb up there. If not, I may be able to just snip it and do it that way. So let's see what we can do. Yes, I can do so. I can just pop there. Right, that might just throw it there. Right, that's there. Just losing that. Losing it. Well, yes. So it's just do a bit of persuasion. Here's a turn out. That doesn't really help. Give it away. Well, also it's on earlier, having measured things, there's several testing modes that are going to go as well. So we actually get this whole lighting assembly problem there. Then we'll see if it shows a method of removing this out from the drive. Well, it doesn't, so it's going to have to get this off the line, so this hanging back. Do that way. You can see all the change, that's why. Once slow down, on the slide down here. Grab a few places on the amplifier settings. That will very reasonable. I'm going to take those out. So my cable is dry screen. I'm going to hold my hands on the power plug. This one screw here, one screw here. Hold those on. That's how we work, that's screws there. Okay. That's the outside of that plate. It's a shame that. Oh, hang on. I just wiggled this lighting thing here and it moved. I'm just wondering whether these two screws here, does that make it looser for the whole lighting block? I can't believe that you would have to can't believe that they made it such a way that to change a light bulb you have to take it all apart and restring it. So at the risk of something dropping down on the inside, although that's self-tapper, yes, that's now made that slightly looser. Tell you what, let's put those two little black threaded screws back in there, because we don't need at the moment to remove those. And let's remove this other top one. Let me show you the overhead camera here. What I'm doing here is there's two screws, one there and one here. I'm hoping, I just wish they put this in the manual if this is the answer, that releases. Yes, it does. Look at that, wonderful. It releases the whole lighting assembly. Great. Right, so there's our festoon bulbs, there's our lamp for stereo indicator. Now I think it doesn't appear to be screwed on. Oh, you can't see what I'm doing, sorry. Let's bring the other camera in. There it is. So this doesn't appear to be screwed on, it just appears to be wedged in there, I think. I'm hoping, or is it just is it glued? That lamp fitted from the other side. Looks like it's obviously got hot, which is why it's burnt out. Yeah. Okay. So what we can do a fairly simple repair on this. Let's just put this connection back on here. Now what I will do is I will just cut this bulb wires here. As we know, the bulb is faulty. red open circuit. I checked it with the meter earlier on, and at the same time we can just quickly go along with our test meter ohms. Don't know whether they'll. That one's okay. That one's okay. That one's okay. That one's okay. I'm pretty sure one of these was not lighting up. Yeah, they all seem to be okay, which is a minor miracle in itself, I suppose. But I'm pretty sure one of those was not lighting up. The illumination on the back of the meter, that was okay. So now what we've got to do is find a 6-volt bulb. I'll tell you what we'll do, because the wires are a little bit tangled in here, I'll just pull that round. I'm pretty sure I've got a 6-volt bulb, but not one with great big long leads. This is why I've decided to cut the other one out. Let's see what we can find. Yep, so I've gone through my stock of old dial lamps and things and managed to find some dial lamps and found one, and there it is, 6 volts. That's what I got my power supply set to. So we have a good working bulb. So it's a little bit short on one side, a bit longer on the other. Put the old soldering iron on and I shall wire this in. This is one of the useful benefits of old bits of equipment that you find that are no longer serviceable, but bits of it might. And I seem to remember rescuing this lamp from something, I can't remember what it was. I thought one day I will need a dial lamp of about 6 volts. And sure enough, that's what I've got. So we pop that into there. And it should fit into that hole much the same as the other one did. And we can drop that whole assembly this. Not dropping into the slot as I would hope it would. Slot position. That's still not going in. I wonder why that is. Trapped anything else in there? I don't think so. Perhaps that bulb is just standing out a little bit too proud. Push it in a little bit further. put some screws in here on a temporary basis for a minute. Trim off these wires here. Quite solid bits of wire, they've got to carry a bit of current, I would guess. Get some sleeving. Cut that in half. One on that. On there, soldering on. Tin these wires as well, I've just trimmed them. Right. Reconnect the antenna. Pinch wide, turn the volume down a bit. And there we have a stereo indicator. Take it off. Yay! So, that's pretty much it for this video. We've fixed all the electrical faults that we need to fix. Just got to do a little bit of tidying up, put that heat shrink on those wires, clean the front, and so on. But the rest of the bits and pieces on the circuitry all seem to be good. Tested a few of the other capacitors that might be a little bit on the leeward side, but they're actually fine. They actually test both in and out of circuit as the right value, so I'm going to leave those alone. It's just the power supply ones I was most cautious about, because they really did show, in fact actually they actually show sign of leakage on the underside. You can't probably see that, but there you go, there's one there that's leaked quite a bit on the underside, so they were definitely on their way out, so I'm glad we've done those. But the amplifier side of things should be okay for another year or two. Thanks very much for watching. Do like and subscribe if you like the channel and you want to see more. I'll see you on the next one. Cheerio.